Okay. Good morning, guys. So today we will see the problems on Poisson distribution, and we also cover the negative binomial distribution. So today I will complete everything on discrete distribution part, and then we'll see when we get time to complete the continuous distribution, uh, if it is there in your internals or not. Because next week, I think Monday you have internal. We will see if I have to include this or not. I will let you know through WhatsApp. But discrete part is there entirely. Okay. So today we only work upon the problems on Poisson distribution. There are total 5 problems, but I have taken only 3. Remaining 2 problems I have shared in the Google Drive. The complete notes is there with solution of the question bank problem. It is similar problem so that you can easily able to do it. So this is the problem from Poisson distribution. So we can just, without wasting time, let us quickly complete this. In a certain factory, turning out razor blade, there is a small probability of 1 divided by 500 for any blade to be defective. All right. The blades are supplied in a packet of 10. So they are mentioned here. Use the Poisson distribution to calculate the approximate number of packet containing no defective, 1 defective, and 2 defective in a blade in a consignment of 10,000 packets. Even though they have mentioned the Poisson distribution in the problem itself, if they does not mention the word called Poisson distribution, you can easily identify that whether the problem belongs to binomial or Poisson by looking at into the probability and the number of trial. As we know, it's a limiting case of binomial. When number of trial goes to very high, your probability of success goes to very close to 0. So here the probability of defective, in our case it is probability of success, which is defective, is 1 by 500, is very close to 0. So that is why it is the case of Poisson distribution. Now point number 2 to note before you have to answer the question on Poisson, that we know that the Poisson distribution P of x defined is m power x e power minus m divided by x factorial. We have seen this. And the mean of Poisson distribution is m, as well as the variance is also m. This part I have told you yesterday in the class. All right. Now, if you look into the problem, the m value is unknown to us. The m value is still not known, which is actually a mean of the Poisson distribution. So the first objective is to find the m value. So how you find the m value? You have to find the m value from the mean of binomial distribution, because it's a limiting case of binomial. Keep this point, note this point. So we have to always find the m value from the mean of binomial distribution. The reason to use binomial distribution is that Poisson distribution is a limiting case of binomial. That's why to find m, I will use the mean of binomial distribution. So therefore, the mean is equal to n into p. We know that n into p is the mean of binomial distribution. So therefore, now what is n and p? Let us define here. So in this case, the p denotes the probability of defective 1 by 500 of any blade to be defective. So p is the probability of defective blade, which is given here as 1 divided by 500. So this is approximately, I think, 0.02. 0.002, I'm sorry. This is 0.002. So you can see the probability of success is very low. Now here n is the 10 value because they are supplying the blade in a packet of 10, so n is equal to 10 here. Substitute, so you will get 10 into 0.002 in this case, so which implies 0.02. No, mean is nothing but m here, so m value we have got as 0.02. That's the first step you have to do always. So find the m value by using the mean of binomial distribution. Any doubt in this? So now we have got the m value. Now let us start answering the question. So don't forget that we are finding this defective with 10 out of 10,000 packets. So now put the value of m in the p of x. So therefore, I will go to the next slide. So here you will get the p of x is equal to, we had the formula m power of x e power of minus m by x factorial, but we have got the m value as 0.02. So I will substitute that here. So this will become 0.02 power x into e power of minus 0.02 whole divided by x factorial. So this is p of x. Now to simplify this further, I will calculate and write the value of e power minus 0.02. So e power of minus 0.02 is 0.9802. This is the value of e power minus 0.02. If you just calculate from calculator, you will get 9802. So that value I substituted here. Then we have 0.02 as it is, power x whole divided by x factorial. So this is p of x. Now this is the p of x. We have got it. So now let us answering the question. So what is the first question they have asked? Use the Poisson distribution. We have got the p of x for Poisson distribution now. To calculate the approximate number of no defective, one defective, and two defective. So let us find first no defective. So first part is probability of x is equal to 0, means no defective. So you have to just put the x value here. So this will be 0.9802 into 0.02 power 0 divided by 0 factorial. So this will become 1, this will become 1. So answer is 0.9802. But you are finding this out of 10,000 packet. So you have to multiply this with 10,000 at the end. So when you multiply this with 10,000, what is the approximate answer? I think you will get 980 approximately, 9802 actually, 10,000. No? So this will be 9802 packets approximately. So what this indicates, out of 10,000, 9,802 packets have no defective blade. This is what it means. Have no defective blades. So don't forget to multiply with the 10,000. If they don't mention this word 10,000 packet, if they don't mention this, then don't multiply. Then this is the probability. Okay. Next part is probability of one defective. So probability of x is equal to 1. You have to substitute everything in equation number 1. So this will be a 0.9802. Then you have 0.02 power 1 divided by 1 factorial. So quickly you can just calculate that. How much you will get it? 0.9802 into 0.02. So here only I will multiply this with 1000 also. 10,000 also, so that it will be easy for us to get the direct answer. So multiply this with 10,000. Just give me the answer. Where is the calculation? Okay. What is the approximate answer? 0.9802 into 0.02. into 10,000. I'm getting approximately 196 packets have one defective plate. 196. Yeah. Oh. So quickly, can you answer me the third question? What is the third question? One no defective, one defective, and two defective, right? So what is probability of x is equal to 2 into 0.02 power 2 divided by 2 factorial, and this whole part should be multiplied with 10,000 because you are finding this out of 10,000 packets. So just give me the answer approximately. 0.9802 into 0.02 whole square divided by 2 into 10,000. I'm getting approximately value is 1.9604. So approximately we can write 2 defective. So 2 packets approximately have 2 defective plates. 2 defective plates. So any doubt in this? Let me know. Alright, so let's go back to the next problem. Similar to this, there is a communication channel. There is a communication channel that receives an independent pulse at the rate of 12 pulses per microsecond. Okay, 12 pulses per microsecond. Now, this 12 pulses is become your n value now. The probability of transmission error is 0.01. So P is also given to us for each microsecond. So compute the probabilities of, you can see in this problem, they have not mentioned anywhere the Poisson distribution. But you can see because the probability is very close to 0, I have to use the Poisson distribution. All right. Even n is also comparatively larger, and probability is becoming very close to 0. We have to use the Poisson distribution. So I can just put in this manner as the probability of success. Probability of success. So in this case, in our case, the probability of success means the probability of transmission error. Okay, which is nothing but the probability of transmission error is actually very close to 0. So we use Poisson distribution. Poisson distribution. All right. So here we have n value is 12 pulses per microsecond. So n is equal to 12. So now the mean is equal to n into p. I have told you we have to use binomial distribution to find this. So n value is 12 and p value is 0.001. So when we multiply this, we will get 0.012 approximately, which is the value of m. So this implies m is equal to 0.012. Now we have got the m value. Now you can write the p of x for Poisson. So this is nothing but m power x e power minus m divided by x factorial. So which is nothing but 0.012 power x into e power minus 0.012 whole divided by x factorial. I can write the value of e power of minus 0.012 separately so that it is easy for me to calculate. So shift e minus 0.012. Okay, the value of this value, the value of e power minus 0.02 is 0.98807. This is the value of this, so I have written here. The rest part is 0.012 power x divided by x factorial. So we have got the p of x. Now we can start answering the question. So the first part is we have to find no error. Okay, we have to find no error. So no error means what you have to do here, you have to just write probability of x is equal to 0. No error at all. So when you put x equal to 0, 0.012 power 0 becomes 1 and x factorial becomes 0 factorial, which is also 1. So you will get only this value. So the only value which you will get is 0.98807. Straightforward answer. Nothing much to do. Second, I can go to the next page. Next is 1 error per second. So I have to find probability of x is equal to 1. So this is equal to 0.9, how much? 0.98807, 98807 into 0.012 power x divided by, this will become 1 now, divided by 1 factorial. So approximately how much we will get here? You can just calculate quickly. I have calculated this, I think, into 0.012, 0.0118 I'm getting. Okay. So 0.0118 568. This is the value I'm getting. Just check it out. Now third, what is the third question? At least one error per microsecond. At least one. So at least one means what? Probability of x should be greater than equal to 1. This is the meaning of at least one error. So greater than equal to 1 means I have to start value from 1, 2, 3 and so on. We have to keep on going. So better than that, I can write this as 1 minus probability of x less than 1. So this will become 1 minus of probability of x is equal to 0 only. So already we have probability of x equal to 0. Previously we have found here. Just put this value. So this will become 1 minus 0.98807. So what is the answer? 1 minus 0.98807. 0.01193. 0.01193. Yeah, correct. We need. Okay, the next is 1 second. Okay, fourth problem. What is the fourth question? 2 errors. So this is straightforward. I will just leave it to you. X is equal to 2. So you know what to do. You have to just put x equal to 2 there. So this will be 0.98807 into 0.012 power 2 divided by 2 factorial. You just calculate and let me know the answer. And the fifth part is at most 2 errors. So at most 2 error is x should be less than equal to 2, which means probability of x equal to 0 will come, probability of x is equal to 1 will come, plus probability of x is equal to 2 will come. Already we have found this value, which is 0.98807 plus x equal to 1 also we have found here. Just put this 0.01187, right? I will round off this digit. X equal to 2, I don't know the value. Can you please tell me what is the value of x equals to 2? Do I have to calculate this? Right. 0.98807 into 0.012 square divided by 2. How much? Not 71 point, it is 7.14 into 10 to the power minus 5. Okay, so this value will be 0.10 to the power minus 5. So 0.0000711. This is the answer. So that part I will plug it here. 0.0000711. So just calculate this. I'm sorry. So I will just quickly calculate this. Plus 0.01186 plus 0.98807. Approximately I'm getting 1. Approximately. Very close. Approximately I'm getting 1. Because I've rounded off this digit. If you don't round this digit and you take this as 5, then you might get 0.9999 maybe. But exactly this is approximately equal to 1. I will do this. So in this case here, X is the Poisson variant such that this condition they have given. I have to compute the mean and variance of the Poisson distribution. So straight away you can just write the P of X, which is m power of X e power of minus m by X factorial. Now this data I will plug it here. X equal to 2 means wherever you have X will come 2. So wherever you have X equal to 4, it will become 4 here and so on. So from the data, from the equation, I can just take this equation number 1. From equation 1, we get, so I can write here, this will be m square e power of minus m by 2 factorial is equal to 9 into, this is 9 into m power 4 e power of minus m by 4 factorial plus 90 times m power 6 e power of minus m divided by 6 factorial. Any doubt in this? No. Okay. So you can take e power of minus m common, both. So e power of minus m anyway cancels out everywhere. So the only term which is left out is e power m square by 2 is equal to 9 m power 4 by 4 factorial. 4 factorial is 4 into 3 into 2 into 1, which is 24. Plus here also e power of m get cancelled, so becomes 90 times m power 6 by 6 factorial. So 6 into 5 into 4 into 3 into 2 into 1, so becomes 720. All right, so this is 3 and this is 8. This will be 8 times. So the expression which I will get is m square by 2 is equal to 3m power 4 by 8 plus m power 6 by 8. So next what I can do is I will take this m square by 2 to the right hand side and I'll make this as 1 here. So 1 into 3m power 4 by 8 into 2 by m square here plus m power 6 by 8 into 2 by m square. So this will cancel out 4 times and this also will cancel 2 times. M square get cancels 4 times and this will become 4 times. So the term which I'll get here is 1 is equal to how much? 3 by 8. Sorry, not 3 by 8. I'm sorry. 3 by 4. 3 by 4 m square plus here 1 by 4 I will get into 6 has cancelled out, so becomes m power 4. So this implies now 4 you can take this side, so become 4 is equal to 3m square plus m power 4. So I will go to the next page. Okay, I don't have space here. Okay. I will solve it here. So this will become 3m power, highest power first I will write. So this is the m power 4 plus 3m square minus 4 is equal to 0. You can easily factorize this. You have m power 4 here and 4 here. So straightforward, this is what? M square minus 1 into m square plus 4 is equal to 0 you will get. So here you will get m is equal to plus minus 1 and plus minus 2i. Because you are talking about mean and variance, so negative value and imaginary values you have to neglect. So imaginary values you have to neglect and negative value also you have to neglect. So therefore the mean is equal to 1. And we know that variance is also same as mean, so that is also 1. So mean is equal to 1 and variance is equal to 1 in this case. Because we know that your mean is equal to m value and even your variance is also equal to m value. So if you found mean, that is same for variance also. So that's it. It's a straightforward factorization, so I will write directly. And it out in this part. We can go back to the next part, which is your negative binomial distribution. Few things you have to note here. The negative binomial distribution experiment is almost same as the binomial experiment, with one difference. That is, a binomial distribution experiment has a fixed number of trial. So as we have seen that in binomial, we have X success. We have talked about X success in N trial. This is what we have done in binomial distribution. So you can see that we have fixed number of N trial, and each trial is actually assumed to be an independent. And we have only two outcomes in that, that is success and failure, where the probability of P is represented with the probability of success, and X is a random variable which represent the success, as I have written here. X success in N trial gives the binomial distribution. But when we talk about negative binomial distribution, it is a reverse case. So what is the reverse case in that? In this negative binomial distribution, the number of trial is not fixed, and your random variable X actually becomes the number of trial needed to make R success. So let me put it in this manner. In binomial, you have X success in N trial. In negative binomial distribution, you have X trial to make some R success. This is the difference. It's a reverse case. So now we have X number of trial to make R success. This is binomial. This is negative binomial. Let us see one example. Let me put in this manner. Okay. In earlier cases, if you just go back to the previous lecture, in that we have done one problem where I have tossed a coin 4 times, and then we calculated the probability of getting, let's say, exactly one head. This is the example we have taken for binomial distribution. So from this example, you note that you have fixed number of trial. Okay, so in this case, what we have here, we have X success. So in our term, success means getting the head. So getting a head is a success for this problem. So now you can see getting a head is a success in 4 trial. So now you can see that we have X success in n trial. So this was the clear-cut example of binomial distribution. So then we have directly written p of x is equal to ncx, p power of x and q power of n minus x, and we have found that this is a different story anyway. So now when I will just change this particular example a bit, so I will reframe this question. So let me take this question as let's say okay, we toss the coin until the first two are head. We are tossing the coin sequentially, means in sequence. We are tossing the coin in sequence until the first two outcome, the first two event are head. So now what you can see in this case, your number of trial, how much number of trial you have to go is not fixed, is not fixed. Until you will get head, you have to keep on do the trial. So number of trial is not fixed. And what is the value of x it may take? What is the value of x it will take? So what is the x for binomial distribution case? We have x trial to make r success. So I have to find the number of trial is not fixed. It means x is not fixed. X is not fixed because x is the number of trial in binomial negative binomial distribution. So x is not fixed, and I'm focusing to find what is the r success. And what is the r success? So let me put in this manner. So let us take x value and the corresponding event. We'll visualize this a bit. So the minimum x can take is only 2 because we are tossing this coin until we get two head, first two head, right? So you may get at the first part itself head and head. X can be 3. So what are the events possible? You may get first failure, then you may get head, and then you may get head. Or possibility is that first success, second failure, and third success. Even in this case also you have two head. Okay. What if it takes 4 values? So what is the event possible for 4? So for 4, the event possible that maybe you get failure, failure, head, and then head. Then you may get tail, head, tail, head. In this case also you have two head now. And then you may have head possible, then failure, and then head. So like that, trials may continue. Now here comes the important note. The last out event of every outcome is always a success. You can just note here. How many times you go, the last event, I can just write here, the last event is always a success. Second. So the last event is always a success. Doesn't matter how many times you do the experiment, the last event is always a success. But I will just rub this part here because I have to do some more analysis. Alright, so I need this space here. Yeah. Okay. So one thing you note here is that the last event is always a success. But what about the previous this one? What about the previous one? What about the previous one? In this previous is the remaining three. So last event is always a success. A success means getting the head. But the previous one, but the previous event, I can put in this manner. The previous event, that is x minus 1, because you have 2, so the previous event is left out is only 1 here. Here it is 3, so previous event is 3 minus 1 is 2. Here it is 4, so 4 previous event is 3, like that. So that is x minus 1 event has how many successes? R minus 1 is equal to 1 success you have. You can see here also you have 1 head. In this also previously you have 1 head. Here also minimum you have 1 head. So last event is always a success. Last event is always success, and the previous x minus 1 event should have R minus 1. In this case it is 1 success. I once again repeat this. You do how many number of times the trial, the last event is always become a success, because for us the success is of getting to a head, and we are talking about head, right? So last event is always getting a success. So this part is sure, but the previous event, that is x minus 1th event I'm talking, also should have R minus 1 success. So R minus 1 means if it is 2 here, 2 minus 1 is 1, right? In this case it is also 1 success. In this case also it is 1 success. Now we have got the pattern. We have got a pattern. We have understood the pattern of event of X trial and R success. So now let us put all this pattern in a mathematical way. So how can you write the probability of X in by looking at this particular pattern? So you can see that the X minus 1 event leads to R minus 1 success. So X minus 1 trial leads to R minus 1 success can be done in X minus 1C, R minus 1 ways. I repeat once again, X minus 1 trial, number of ways X minus 1 trial leads to R minus 1 success can be done in X minus 1C into R minus 1. Then we have the probability of success into power R minus 1, because you have probability of success, previous one is R minus 1 success, right? Into the probability of failure should be X minus 1 minus of X minus 1 minus of R minus 1, and into the last event is always a success, so that is into P. So now when you put this all together, P into R, P in power R minus 1 get cancels out. So this will become X minus 1C R minus 1. This will become P power of R, and this will become Q power X minus R. This is the P of X defined for binomial, negative binomial distribution, where X can take the value R, R plus 1, R plus 2, and so on. So this is all the history. So I can just put this in a standard form. The point which you have to remember is for binomial distribution, for negative binomial distribution, your P of X is nothing but X minus 1 C R minus 1 into the probability of success power R into the probability of failure power X minus R. So don't forget that here you have X is equal to number of trial, which is not fixed, which is not at all fixed. How many trials you have to go, that is not fixed, and R represent the success in X trial. In X trial. So X minus 1 means the previous event, as we have spoken about here. So as we have seen that head was the success we are talking about. So if the last event is always a success, the previous at least one R minus 1 success you should get it. All right. So this is the only part you have to remember. Then the mean of this is, I will just give you directly, is R by P, and the variance is equal to R into 1 minus P by P square. There is no derivation required for this, only this part you have to remember. That's it. The probability distribution X is the number of trial, R is the success in X trial, and the mean and variance. That's all. Any doubt in this? Okay. You are surveying a people exiting from the polling booth and asking them if they voted independent. Okay. The probability P that a person voted independent is 20%. All right. It means the probability of success they have given, which is 20%. So I can just write parallelly. So here the P value is 20%, which is nothing but 0.2. All right. What is the probability that 15 people must be asked before you can find five people who voted independent? Understand this. What is the probability that 15 people must be asked before you can find five people who voted independent? So in this case, anyway, X is number of trial. We'll talk about that. So what is the X number of trial? 15 people must have been asked before. So it is 15 people. And how many success? 5 people you have found who voted independent. So R, which is the success, is equal to 5. So the negative binomial represented with X, R, and P, generally, we have the formula X minus 1, C, R minus 1, P power of R, and Q power of X minus R. So if P is 0.2, what is Q value? Q value will be 0.8, 1 minus P. So the negative binomial of 15 trial, R value is 5 and probability is 0.2. Just put this here. You will get 14 C 4, R is 5, and this is 0.2 power. R value is 5, and this is 0.8 power X minus R. So 15 minus 5, 10. So can you just quickly calculate and tell me what is the probability? Can anyone tell me the answer of this? All right, so we have got the value as 3.4%. All right, this is the last question of today for negative binomial, and then we are done for today. Read the problem. I hope you like this example. In an NBA National Basketball Association Championship Series, the team who wins 4 games, this is important, team who wins 4 games out of 7 will be the winner. Okay. Suppose that team A has the probability of 0.55. So probability is 0.55. If P is 0.55, what is Q value? We will see that later. Okay. Team A that has probability of 0.5 of winning over team B, and both teams face each other in the championship games. Now here comes the question. What is the probability that team A will win the series in 6 games? Okay, so let me put this in this manner. So we are finding the negative binomial of X, R and P. So let me first put the value. What is X now? What is the number of trial? What is the probability that team A will win the series in 6 games? So X will be 6, right? Then what is the success? R. 4 games minimum they have to win out of 7. So R becomes 4. And the probability is 0.55. So just substitute in this. So you have X minus 1, CR minus 1, P power of R and Q power of X minus R. So X minus 1, CR minus 1, how much? X minus 1 is 5, C3. This will be 0.55 power 4. What is Q value? 1 minus 0.55, 0.45. So this will be 0.45 failure of X minus R. So X minus R is 6 minus 4, which is 2. Just calculate this. You will get approximately, I have calculated this already. So this is 1.1853 approximately. All right. Now second, what is the probability that team A will win the series? All right. So team A will win the series if they win all the 4 games out of 7. So if team A win all 4 games out of 7, then they win the series. So how to answer this question? So therefore the probability of team A win series is equal to, what is the X values it will take now? Because if they have to win all the 4 matches, so X will be 4, 5, 6 and 7. So X will take 4, 5, 6, 7. 4 match, 5th match, 6th match, 7th match, they have to win the series. So X will be equal to 4, 5, 6 and 7, straightforward. So this will becomes the negative binomial of, we have negative binomial of X, R and P. So they have to win 4. And what is the success? All the 4 they have to win with the probability of 0.55 plus negative binomial of 5th match also they have to win. In the 5th trial, 4th success is 4 only with the probability of 0.55 plus negative binomial of 6th trial success should be 4. Okay, and the probability is 0.55. And the last is negative binomial of 7th try, 4 they have to win with the probability of 0.55. So in 4th trial, all the 4 they have to win. 5th trial, 4 they have to win. 6th trial, 4 they have to win. And 7th match, 4 they have to win. When they win all this scenario, team A will win the series. So you can just calculate this part. So this will be x minus 1. So this will be 3c 3 and this will be 0.55 power 4 into 0.45 power 0 plus here you have x minus 1, so 4c 3 0.55 power r into 0.45 power x minus r, so 1 plus 5c3 into 0.55 power 4 into 0.45 power x minus r, which is 2, and plus this will be 6c3 0.55 power 4 into 0.45 power 7 minus 4, which is 3. So just calculate this part. I've already calculated, you can check that later. So 6083 is the approximate answer. One second, I just forgot to. Okay. The last part, the last part I will leave it to you for the answer. If both teams face each other in a regional playoff series and winner is decided by the winning 3 out of 5 match. So 3 out of 5 means your x will take the value 3, 4 and 5. Got it? And in this case your success will be r is equal to 3 because 3 matches you have to win, so r will be 3. So all the three scenario you have to take, so then team A will win the playoff. So like that I have written here. Similar manner, you have to write the probability of A win the playoff, which is equal to, I'll just write directly, negative binomial of 3. Now success is also 3 in this case with probability of 0.55 plus 4th match success is 3 with probability of 0.55 plus negative binomial of 5th match 3 success with probability of 0.55. So just put the formula and calculate this. So answer is approximately 0.5931. You can just check this out.